Teresia, I think if you're ready, we can start, and then people can join their own time, probably during the general introduction to the webinar. But I think it might be a good idea to start already.
Yes, thanks, Aino. Good morning or afternoon, everyone. Welcome to this webinar on bridging data and action, leveraging greenhouse gas research to drive policies and renewable energy in Africa. Now, that's a long title, but the idea with this webinar is that we look at the two main projects here, which are KADI and LIPRI, and related projects, and see where we can find points of convergence and also look forward to future collaboration. So we will first start with a brief look at the agenda before we go into the presentations. So I am doing the welcome now, and then I will give the floor to Yona Leverk, the LIPRI program coordinator. That will be followed by a brief presentation about the KADI project, which is a partner in this webinar.
Thank you very much, Teresia. Good morning to all of you. So I guess the majority of the people here is already familiar with what LIPRI is. So in a nutshell, LIPRI is the long-term partnership between the African Union and the European Union on renewable energy. And the main features of the partnership rely on our capacity to organize calls for projects. So currently we have an open call, LEAP Sustainable Energy Co-Fund, which is open until March. So you are kindly invited to check the terms of reference of the call, which are available on the project website to get further information on the details of the call. Thanks to this co-funding mechanism that involves both funders on the African and European continent, we've been in capacity to organize 2 calls for project and then the third that is ongoing. And through these calls for project, we've been funding 31 projects, research and innovation projects that for the majority are still ongoing and that mainly address several thematic priorities that are very much linked with climate resilience and climate services. So first of all, we have a set of activities that address intelligent system to facilitate access to energy, such as microgrids or decentralized solar system that can play a role in supporting renewable energy access, particularly in off-grid areas. So these solutions can provide localized, reliable energy solutions, but they also reduce the dependence on fossil fuels and the contribution to emissions mitigation. On another hand, they also help vulnerable communities to adapt to climate change and to improve their energy access. So this thematic priorities related to autonomous intelligent system is absolutely key for us to create this connection between renewable energy solution on one hand and climate resilience and climate services on the other hand. Another important topic that we address are the smart grids that we try to develop at different scales for off-grid solutions. So smart grids, they provide dynamic energy management that can respond to the viability of renewable energy sources, like solar, for instance. And they also allow localized resilience for climate fluctuations. So these technologies can help in planning and managing the future energy needs of the African communities with a specific focus on the remote and undeserved areas, which is absolutely strategic when we address sub-Saharan African countries and regions. We also have an important set of activities on clean cooking technologies, modern cooking technologies, domestic uses. So we try to develop renewable powered cold chains and solar cookers prototypes that can contribute to improving the public health, but they also can contribute to reduce greenhouse gas emissions, preserve food. So for us, it is absolutely vital in the face of climate-induced issues to address this, also related to food security. And finally, we have a specific priority on the productive uses in the agricultural sector. So we try to develop activities, demonstrators, and prototypes that can enhance agricultural productivity, as solar-powered irrigation, food processing devices. So we consider these are very much linked with climate resilience, because these systems can improve the efficiency of water uses, and many other topics, like also the need to predict weather patterns caused by the climate change. So I invite you to pay attention to the list of projects that we have been funding in the LIPRI portfolio. I confirm that I have no slide for this introduction, so this is normal, Theresia, that the slides are not moving. So the implementation of these solutions that I was putting the focus on, like renewable energy system, agricultural technologies, or clean cooking technologies, are key for us to increase research innovation in the field of renewable and sustainable energy, but also to reduce emissions, to improve livelihoods, and then to have the capacity to address both adaptation and mitigation challenges. So I guess these topics will be further addressed during today's webinar, and I will stop here. Yeah, over to you, Theresia. Thank you.
Thank you very much, Leona. Thanks for also emphasizing the links between the energy projects and the effects of climate change. Now we'll go to the KADI project, and please have a brief introduction from Matt Saunders from Trinity College, Dublin.
Brilliant, thanks, Therese. Yeah, so welcome everybody. I'm going to give a brief introduction to the KADI project, which is focusing on knowledge and climate services from an African observation and data research infrastructure. So it ties in with today's seminar. So when we think about one of the aims of KADI, it's really to provide climate information in the form of climate services that aid decision making in a whole range of sectors, that link across different systems. Next slide, please. Can I get the next slide, please? Okay, and just give some background. I mean, this is important from today's webinar, but important because we think about the impact of greenhouse gas emissions and the negative impacts of climate change, and the fact that this is a global issue, and historically Africa is not responsible for these sorts of emissions, and that it's becoming more and more affected by the impacts of climate change. In addition to this, lots of the kind of land mass of Africa is switching from a sink of greenhouse gases to a source of greenhouse gases over recent years. Next slide. In order to kind of address these sorts of issues, what Africa really needs are a strong voice at the key policy meetings, and also the climate services to be able to support mitigation and adaptation to climate change. But both of these are really important, in the fact that they need support from both science and the scientific observations that underpin the science that feeds into this. Next slide. So we think about the science behind it. We can see that the greenhouse gas emissions are increasing. There are lots of different sources and sinks. These are influenced by weather and climate. They're influenced by human activities. But one of the key aspects here is they're incredibly complex. They're incredibly interlinked with each other. And in reality, we don't really know enough about the emission dynamics, the sources, the processes that drive them, how we feed this into mitigation and adaptation. So what we need to do, and this is what KADI is working towards, is really empowering African scientists to provide the data and the necessary knowledge to provide the climate services that are required. Next slide. And this work, the KADI project, builds on a previous project called SecraFog. And from the greenhouse gas context, one of the key outputs of the Secret Fog project was to really do a deep dive to understand, what are the variables that we need to think about, and then how do we need to assess these and measure these to be able to provide the information for the climate services. So this project came up with essentially an essential set of variables that we need to measure in the African context that feed into this sorts of research infrastructure design. Next slide. And one of the key things that this project kind of highlighted, and where KADI has really picked up, is really how we need to strengthen this from the ground up through African ownership, and to develop a Pan-African network of cooperation for climate science through common research projects, promoting knowledge exchange, and regular kind of community of practice. So we need to get the community to kind of take ownership of these approaches for them to be successful. Next slide. And the project is also kind of working towards actually defining, what is it that we actually need to do? How do we define what the necessary science is? How can we guide the investments into these research infrastructures and develop a blueprint, a framework for those research infrastructures, and then to translate, the information and measure the impact of the science that we produce. Next slide. And what we're doing then with this in terms of the research infrastructure design in KADI is to look at the climate services needs that are derived from the key stakeholders, and to really then identify, how we go about, how we map those onto the infrastructural gaps, what's required, and how that kind of scales between domains, from operational domain right the way through information, knowledge, society, and then also thinking about those kind of cross-cutting issues that kind of that move between them in terms of open science, feedback mechanisms, impact pathways, these sorts of things, to really kind of create a cohesive research infrastructure that can provide the climate services that are needed. Next slide. And so how do we do this? How do we provide science for the people? How do we get the science to the people? And one of the first things that the KADI project has really been doing is listening to the people, engaging with stakeholders from the bottom up to understand, what do the stakeholders need in terms of climate services, and then to kind of, build that into kind of what they need from the scientific and observational perspectives to inform that decision-making process to empower people to take the next step. But this is challenging because there's lots of different stakeholders and all of them have very, very different needs. Next slide. And what we're trying to do in KADI is to go practical with this. So we started at the bottom in work package 1, and you'll hear more about this later, in terms of engaging with stakeholders in a co-creation process to identify what's needed to develop those climate services. We then trial that through a number of pilots projects within the project itself, from Earth systems modeling to city studies to ocean biogeochemistry, and thinking about what we've learned from long-term research infrastructures previously in Africa, to then inform a work package that's focused on the blueprint for that network design, that we can start to come to a kind of a combined African observational network that gives the climate service information that we need. Next slide. And we're doing this through kind of a climate service co-creation process to create these sorts of stakeholder maps and flowcharts that kind of give more information in terms of how we move from the definition of the climate service and the identification of that in terms of what we need to do in terms of gaining data, and then feeding that back into the stakeholder process as well. And you'll hear more about these sorts of stakeholder maps later on today. Next slide, please. But what we also need to do is then take that information and then build that in from these emerging ideas into the infrastructural network that's required. So there are multiple work packages within the project kind of moving together to take this information that's being co-created by the stakeholders, and then mapping that into or aligning that with the research infrastructure that's required to provide those services in the long term. Next slide. And the other aspect of the project is the importance of knowledge exchange. And what we've done is engaged with scientists across Africa to develop training programs and mobility of scientists to identify key stakeholders and stakeholder champions that are working at the forefront of these areas across Africa, and to develop regional hubs and community of practices to enable knowledge exchange between different areas within Africa. Next slide. And then we have an outward-facing piece as well in terms of communication. So linking the outputs of KADI and the work that's going on into key events in terms of policies such as COP events, and also at key kind of science events such as the EGU and AGU. Next slide, please. And then where are we going afterwards? I mean, we're as KADI, we're in the final year of the project now, and we're starting to build this infrastructural design. What we're doing now is then establishing this network and maintaining this exchange of information and community of practice to kind of create this kind of pathway that then will enable the implementation of the research infrastructure aspects that are identified as funding becomes available. Next slide. And then finally, kind of taking these next steps, it's kind of, identifying the network design, thinking about how we can build this feasible infrastructure and looking at new aspects such as, emerging technologies and infrastructure, to going out and finding the resources to kind of, fund this and to implement this in the long term, building the communities of practice and getting African scientists, connected and communicating, with each other, with ourselves, across the world, to then build a really nice global network that can deliver the research infrastructure and the climate services that Africa needs. And I'll finish there. Thank you.
Thank you very much, Mark, for that comprehensive presentation. I'm reminding the participants, please use the chat, introduce yourself, put what your expectations are for today, ask questions. We will have time for Q&A, but as you know, 2 hours is not enough. We can do follow-up based on what you put in the chat as well. The next presentation will be from the Horn of Africa, from Titike Bahaga, who is the project coordinator for several projects. Titike, if you are ready, you have the floor. And right after his presentation, we'll have time for a few questions. So if you have questions, wait for after this presentation. Titike, are you ready?
I'm preparing my slide. Just a second.
Okay.
Do you see my slide?
Yes. Good.
All right. Thank you. My name is Titike Bahaga. I work for ICPAC, IGAD Climate Application Center, based in Nairobi. Thank you for the organizers to inviting ICPAC and share, some of the things that we do across climate service value chains. I would just take you through, some of the that we do at ICPAC, but maybe I would also on some of the European Union projects that we involved in. So ICPAC is IGAD Climate Prediction Application Center, and initially it was established at Drought Monitoring Center at Nairobi, and then signed a regional organization, IGAD, where the map you see, the pinkish color is IGAD countries, with including the other color. So that's where we operate. So we have 11 countries, and we are a designated WMO Regional Climate Center. Also, we have status in FCC. So our vision is to become a world-class climate center. Mission is to foster climate service. I have some issues. Maybe can I move this thing here? So the mission is to foster climate service knowledge, enhance the community resilience, and the main objective is to contribute to the livelihood of the communities in the region, and mitigate, the hazards and disasters. East Africa is one of the hot spot for extreme climate events, and the seasonal rainfall is highly impacted by global drivers like El Nino, and also Indian Ocean dipole. I'm just showing you a series of extreme climate and their impacts. So it's a kind of a hotspot drought. So maybe I just want to start from 2020 and 22. We had a kind of consecutive 5-season drought that lead to a loss of 10 million cattle worth of $2 billion. And due to El Nino 2023, the region actually experienced one of the worst floods and impacted, and people and the resources has been washed away, and landslides in Ethiopia recent time. So just to indicate this is a kind of hotspot. So what we do at ICPAC is we provide products or generate products and provide services. We focus on, of course, generating climate information. So we do monitoring, forecasting. We also do research on climate change adaptation. We have sectors, for example, agriculture, food security, water, and we have a unit where we use as observation for environmental monitoring. Disaster risk management is one of the big program. And we also have a sector where we monitor food security. And we do capacity buildings at, the technical capacity building for production of climate service and, dissemination. And also we also build the capacity of users and the stakeholders and communicate with different channels and platforms. So these are some of the products that we generate. We start from, early level. We monitor, cyclone development, for example, in the Indian Ocean, also provide weekly extreme rainfall forecasts, and we have also a monthly outlook for rainfall, temperature, and we have seasonal outlooks, and and also we provide climate change analysis using Codex and CMIP outputs. So we use a regional climate model for some of our products, and we also assess and best create global seasonal forecast, generating different global producing centers, including the CMWF and North America and European models. So we have different methods to post-process those kind of information, and finally we kind of generate a multi-model, a multi-method average forecast. That's how we presented a tercile forecast based on the ensembles and handcasts provided by global forecast systems. We also generate some information on the conditions of climate change production, and as you can see, if you look at the different scenario, social planning scenarios, it seems that the region is actually one of the region where you see clearly a warming. And so how do we engage users? We have different platforms. One of the major one is called Greater Horn of Africa Climate Outlook Forum, where we bring more than 200 stakeholders and users, and we do co-production, and we kind of assess the past season and provide the upcoming seasonal forecast information and generate advisories for different sectors. We focus on, as I mentioned, DRM, water, agriculture, livestock, energy, and also health. And we finally kind of generate a bulletin and advisories for different sectors. Furthermore, we go also support national climate outlook forums across 11 countries in the region. Also, the user engagement, for example, participatory scenario planning events, smallholder farmer engagement, and we build the capacity in use and application of climate information for different planning. We also host one of the center in Africa, where we have disaster operations centers, a part of Africa Union initiative, also some UN DARAR, and where we monitor some of the climate hazards, and we also coordinate early action and rapid mapping of impacted areas and do capacity building and anticipatory action. We have also a one-stop shop.
Just a reminder that you have a couple of minutes left.
Okay, yeah, sure. This is the kind of East Africa hazard word where we kind of put up our informations, climate information, agricultural outlook, and other drought information. And we have also a drought monitoring platform where we combine, 3 indicators to provide a combined drought information. We have some, documents, strategic document, including East Africa Regional Roadmap for Anticipatory Action. We have also IGAD Food Security, Nutrition, Resilience Analysis Hub, where we have, a kind of FSNWG, a large group where we discuss different aspects of food security, and we do a number of capacity buildings, as I mentioned earlier, focused on building the capacity of climate forecasters across the region, also users and stakeholders. And so we do communicate with different channels. We use our websites, we publish bulletins, and we do organize webinars, forums, and use our social media channels. Maybe just to mention, some of our activities have been, supported by the Horizon 2020 project that's been CONFA, which focused on co-production climate service and water and agriculture sector, where we have, developed some tools to help us to forecast inflow and flood forecasting. This has been a project from September 2020 to September 2024. This project has been ended. Now we are working. We also benefited another project called Anticipatory Climate Adaptation for Community in Africa. It's another Horizon 2023 funded project. It has started in October and will last until 2020. This project focused on flood prediction in East Africa and cyclone prediction in Madagascar based on sub-seasonal forecasts. So we do some publications. These are just a list of high impact publications, and we have of course challenges. And let me finish that here. Thank you so much.
Thank you very much, TTK, for this comprehensive presentation and also for keeping to time. That was quite nice of you. So now the floor is open for questions. I see there was one in the chat which has been answered already, but now is the time where you can unmute and ask questions to the speakers who have spoken so far, from KADI, from Libri, and also from these 3 projects that TTK just presented. It looks like the speakers were very good and we don't have any questions. Do I assume that? No questions. Well, I have a question for TTK. What will you give as the best approach for stakeholder engagement? I see that you've done a lot of that. What is the best approach and how has that worked in these projects that you have been involved in?
Thank you for that important question. The main challenge in across climate service value chain is building stakeholder engagement. So for ICPAC, for long, this Greater Horn of Africa Climate Outlook Forum has been the major ones. where we bring, country representatives. We are regional organizations. We work across 11 countries where we bring these stakeholders, for different sector, and we co-produce climate information services. So maybe a good example for Comfort project was actually focused on agriculture and water sector, and also energy included. So we started mapping the needs of the users and stakeholders. And the product that they are actually looking for, and we co-produce the product that has been identified as the major ones, those ones who require improvement. Those are a new one that's supposed to be added. So we have kind of used a survey where we have collected more than 600 informations of participants, and based on that, we did co-designed, for example, flood information product or seafloor product with stakeholder users. And we co-produce it from the inception, calibration, and all the way to operationalize. I think that kind of engagement is important. Besides, this is a kind of a larger group, but to reach out a last mile user, I think this focused group engagement is also, we find it very, very important. What we call participatory scenario planning and smallholder farmer engagement and building the capacity has been a really important one. And I believe that's the best way to reach out, but it requires resource to reach out, a larger group. Even just forget about the region, even the country. But those example has been really identified a good ones.
Thank you very much. That was very eye-opening. We have a couple of minutes, and I will ask another question to you and to. Oh, okay. Suzanne Oyango would like to speak. Good. Suzanne, you have the floor.
Okay, thanks. A quick question. I guess it also goes to the second speaker, but maybe the first speaker may also be in a position to chip in. In terms of the services that you say you provide, the ones related to risk warning and environment monitoring, that would usually be drought and floods in terms of predicting weather conditions. Would it also include things like locust invasions or armyworm invasions? I'm asking this because the project I'm involved in aspires to, at some stage in time, have an agriculture-based project, and that kind of information would probably be useful for us if we came to when we get to that point.
Okay. Yeah. Thanks a million for the question. Not directly, or kind of. The answer is yes and no. No, we haven't directly focused on things like early warning things for pest invasion, but we have obviously been working very close with things like meteorological observations, and there's a large part of the project that focuses on the lessons learned, through the Kenyan Meteorological Service, and Patricia's online today, and we had to talk a little bit more about that perhaps as well. But I think what we're also doing is thinking about the kind of the approach and the theoretical framework that's needed to provide those climate services. And that's really what KADI is kind of moving towards, to develop this kind of this blueprint framework that if there's a climate service that a key stakeholder needs, we use the kind of the system mapping approach and that co-creation approach to understand what information is required and then how do we build that into the kind of the blueprint design for the research infrastructural framework. So the point here is that we can't, within our project, kind of cover everything directly, but what we can do is create a framework through which, other kind of key pressures in terms of climate service needs can be added to the infrastructural framework using this approach, using this blueprint design. So we haven't kind of covered that specifically, but we're creating the platform and the ability to integrate those needs into the research infrastructure design of the future.
Okay, thank you.
Thank you, Mark. I think we should move to the next presentation. We can continue the discussion after we have these next two presentations, which will be case studies of climate services from East Africa. So the first one is from Patricia Nying'o, climate scientist at KMD, and she will have the floor now. Patricia, are you ready?
Yes, yes. Thank you very much. Doreen, are you sharing screen or do I share my presentation?
I think if you can share it, it will be easier for you.
Okay. Or if you can kindly confirm that you can see.
Yes, it's good. Now,
All right. Okay. As mentioned, my name is Patricia Nying'ura and have been working on KADI project. And for this talk, I will aspects of designing climate service under the KADI project. While listening to Matt's presentation, kind of complements my work
Patricia, I don't know. I don't know if it's.
relatively.
I don't know if it's me, but the speech is quite sloppy.
Yeah, I think there's some problem with the connection.
Yeah, I
The
think the
audio is
connection is
not
not
so good.
sloppy. Yes, now I
Is
hear
it
you
better
well,
now?
but when you were speaking, it wasn't. Now try again. Maybe there was something wrong. Yeah.
Okay, I was using
Okay.
earphones because I'm in a bit of a
Okay.
public
Now
place.
it
But
works. It
okay,
works better.
all right. Let me try share again.
Mm-hmm.
Yeah. So as I was mentioning when I listened to Matt's presentation, it's very similar to what I'll be talking about today, but I will focus mainly on Nairobi and Kenya and how we've gone about designing climate services to fill existing gaps. So to start with, look at the KADI objective, and one of it, or in short, is to build a comprehensive concept for an African research infrastructure. And the focus mainly was on greenhouse gas observations. And I think that is also why this is very relevant for the LIPRI project and collaboration as well. So, in order for us to do that, we started by actually identifying the initial steps to support us in developing a concept for an Africa research infrastructure. And we realized that collaboration becomes very important. So that we identify organizations and researchers from other parts of the world who have successfully developed their own research infrastructures to learn from them and also to get the support to design our own. We also realize that we need to identify what gaps exist in terms of climate services and what needs are new and emerging from the local communities and from various stakeholders. And for this, we also needed to identify who the stakeholders were that we already work with and who are additional stakeholders we can work with, and then engage with those stakeholders continuously, and finally work towards co-creation of services that actually address the local needs and are not simply driven from a research perspective. So these were the initial steps or the initial conversations that we had as we prepared to engage in the KADI project. So to enable us to do this, we carried out a survey. We designed a survey with the help of partners from Meteor Swiss. And the main objectives for this survey, and as reflected in the questions, was one, to identify key sectors and stakeholders that are in need of climate services. Now, at the Met, we already have stakeholders that we work with, but we also recognized that there are many more who could exist that we are not aware of that may need climate services. And so this survey went to existing users, but also asked them to link us to additional stakeholders that they feel would need this. And from this exercise, we were able to identify additional stakeholders, particularly for air quality and also for provision of heat early warning services. We also wanted to understand the needs and current climate service solutions. As climate change is taking a hold, there are increasing needs and services that we were not previously providing that have become even more useful now. And so, for example, heat is one of them. And so, from interacting with our stakeholders or asking them to let us know, then we would be able to fill the gaps and address the needs that they have. The survey also would help us to determine the observation and modeling capacity, including what infrastructure is needed. So we would be able to look within the Met department and see what capacity do we have in terms of equipment and human resource as well, and what the needs are if we are to adequately provide or support research infrastructure and address the needs of climate service needs of our users. And finally, to identify data and knowledge gaps, as well as the current use of climate-related data and services. And so with this particular one, we asked questions that help us to surface or find out what additional data is existing out there that we can be able to incorporate with the development of focus from the Met department, as well as how do people, stakeholders, use the data that we provide for them. And so the results from this survey were actually very eye-opening. We identified additional stakeholders we could work closer with, but also we identified needs that we previously were not serving that will help us as we continue to improve our climate services. Now, one particular work package within the KADI project, as Matt had mentioned, is on pilots. And for Nairobi, in as much as when we were starting the project, the priority or the suggestion was actually to work on greenhouse gas observations. But from our interaction with stakeholders and from looking at what the needs are, we identified that adaptation is actually the priority. And the KADI project mentions that cities are complex. Identify cities as complex societal systems for climate services. Completely agree with that. However, for us, we felt that there is an immediate need for heat early warning or focus compared to pollution information, even though gaps exist for both areas. And our focus for this particularly was on informal settlements. And our aim with the informal settlements is to determine the climate service needs for adaptation to urban heat stress as driven by the users. And these users are the residents of these informal settlements. And with them, we would work to co-design climate services and incorporating also additional relevant stakeholders who will support the adaptation. And so we, as part of the survey, as part of the work that we did, we had a meeting where we sat with members of these informal settlements, talked with them about the various thresholds for heat. We were able to identify, or we recognize the fact that heat extremes are increasing in this part of the world, and especially in urban regions, but they're not being recorded as extreme events or as being hazardous, and therefore we were not providing any information with respect to them. So by interacting with the stakeholders themselves, we were able to identify that this is an immediate need for them, as it directly affects productivity and also their health. And so we designed then this work package, this pilot for Nairobi, to focus particularly on heat. So what benefits have we accrued and we see us accruing as we go forward? So one, we have had closer working relationship with the users because they recognize, or we jointly recognize, that in order to provide the information that they need, we need to have regular iterations where we provide a product and they let us know if it meets their needs. Another benefit is that we've been able to generate data to support validation, and this is ongoing. With the support of another city pilot, we are looking at incorporating citizen science more so that we can collect information from the residents of informal settlements, validate it, and actually add it to the data that we use to be able to support validation. And then we are also able to identify the thresholds for risk with respect to extreme heat. And this is by directly working with health practitioners and the people living in the informal settlements and other researchers. We also have been able to leverage on baseline work that has been
2 minutes left, Patricia.
Thank you. Done prior. We have been able to address user needs, and we are working towards supporting adaptation planning. And through this, we've also been able to gain the interest of the county government, since they're the ones who will support implementation of adaptation options. And this is just to show the Nairobi City Pilot Climate Service design, and it's based largely on heat, incorporating various stakeholders and looking at the direct benefits that we expect to get, with them being reduced illness and improved work efficiency, and in the long term, resilience building and improved quality of life. And this just shows some of the stakeholders that for this particular product on early warning for heat would be involved. So policymakers, local government, community members, researchers, data providers, health practitioners, scientists, and also private businesses. Thank you.
Thank you very much, Patricia. Thank you also for keeping to time. We will not have questions immediately on your presentation. We will go to the next one by Violet Jonas Masaba from Tanzania Met, and she will present the Focus Africa project. Violet?
Yes, thank you very much, Teresia. Just gonna share my screen in a bit.
Mm-hmm.
Can you please confirm if you can see my screen?
Perfectly. You can go on.
Thank you very much. So my name is Violet Jonas Masaba. I'm a meteorologist working with Tanzania Meteorological Authority and the Meteorological Cooperation Unit. But along with that, I have been the focal point of the project Focus Africa, which is mainly what I'm going to talk about today. So the United Republic of Tanzania, through Tanzania Meteorological Authority, is among the countries implementing the World Meteorological Organization project titled Full Value Chain Optimized Climate User-Centric Services for Southern Africa, in short form, Focus Africa. It was a 4-year project from 2020 to 2024 with an extension of 3 months. So the Focus Africa project, the main objective of the Focus Africa project is to develop the tailored climate services in the SADC region, specifically for the sectors of agriculture and food security, water, energy, and infrastructure. The project is being aimed to demonstrate climate services for the 8 case studies in 5 countries, including Tanzania. Others include Malawi, Mozambique, South Africa, and Mauritius. And it has been involving a wide range of stakeholders. And specifically, Tanzania has been participating in implementation of case study 4, 5, and 6, which are agriculture and food security, infrastructure, and energy, respectively. And as I have said, the project has been implemented in 5 countries, piloting 8 case studies, as you can see here. It included South Africa, Malawi, Mozambique, Tanzania, South Africa, Mozambique, Malawi, Tanzania, and Mauritius. And it involved the 4 sectors: food security, infrastructure, energy, and water. And some of the stakeholders involved included land bank, local farmers, INAM, TARI, ASSET, IET, TANESCO, EDF, and water resources. And some of the researchers included WITSI, BSc, WMC, and so forth. So the hydropower energy in Tanzania is of critical importance for meeting the nation's energy demands. And if I may mention, the hydropower is like the main source of energy in Tanzania. And they depend mostly on particularly rainfall in exerting a significant influence on its operations. So the Tanzanian energy provider, Tanzania Electric Supply Company, TANESCO, heavily relies on weather forecasts from TMA to make informed decisions about hydropower generation. However, the absence of tailored weather forecast specifically for hydropower production leaves TANESCO to independently determine the sector's potential outlook based on general rainfall and temperature forecasts. Now, to the right is a picture of a newly developed hydropower plant. It's called Julius Nyerere Hydropower Station, which is expected to provide 2,115 megawatts, which is a game changer for Tanzania. And this calls for an immediate tailored weather forecast specifically for the hydropower sector in Tanzania. So to address this critical limitation and improve climate services for energy in Tanzania, the KADI Study 4 under the Project Focus Africa through the partner WEMC introduced the development and implementation of a dedicated hydropower model, which is aimed at providing hydropower forecast. The main aim of this hydropower model is to provide with TMA and TANESCO a robust, specialized hydropower model that will lay out the hydropower forecast, which will optimize the provision of climate services, enhancing of operational efficiency and overall performance. And through this hydropower model, the Tanzanian energy sector seeks to enhance its ability to anticipate and harness hydropower production effectively, mitigating uncertainties and maximizing the utilization of available resources. To the right here is a picture of one of the stakeholder engagement workshop we have had in Tanzania, where we met with experts from Tanzania Electric Supply Company, and it is where the company WEMC had portrayed the hydropower model, and to make sure that they are aware of how it works and all the technicalities. So to validate the effectiveness of this hydropower model, the model was compared against historical data from TMA and TANESCO and real-world case studies. This was declared by WEMC, where they had done some research in Europe on the same case, and to demonstrate its potential to offer more accurate and reliable prediction for hydropower generation. And also for sustainability and maintenance of the hydropower model, TMA and TANESCO experts have been involved throughout the model generation. So in addition, to make the hydropower model outputs readily accessible and useful for end users, the Energy Case Study team created a web application design or a visualization tool, if we may call it, for effective the dissemination of hydropower products. And this tool is providing the historical and forecasted data on inflow and hydropower generation. It also provides plots for historical and forecast data, and someone can also download this these plots for historical and forecast data. So the end user TANESCO expressed strong interest in the visualization tool or the web application, and they found it to be user-friendly. Now that was the part on the hydropower energy in Tanzania, which is like the major source of energy in Tanzania. Although we have wind and solar energy where the government of Tanzania is planning to invest on it, and we've had the UK Met Office who are the partners of the project and researchers for this case study, and they have done some analysis on potential for wind and solar energy in Tanzania, with the hope that this information is going to help TANESCO in decision making and planning in the future when the government finally decides to invest in wind and solar energy in Tanzania. In conclusion, the success of the project was greatly influenced by the active collaboration between project partners and end users, facilitated through both virtual and in-person interactions. Several missions, probably 4 to 5 missions, successful missions were held in Tanzania. And this helped us to gather requirements, which ultimately led to the co-development of the hydropower model, but also the wind and solar projection analysis tailored to the country's unique needs. And to the right here, you can see some of the pictures of during the missions that were held in Tanzania with some of the stakeholders and some of the partners of the project. And that calls the end of my presentation. Thank you very much.
Thank you very much, Valiet. That was very concise. And now we will give the floor to the participants to ask questions. So you can ask questions for Patricia, who is no longer here. She had to catch a flight, and also to Valiet. Or even from the previous presentations, if you have now thought of something that you wanted to ask. Yes, Titike, you have the floor.
Yeah, thank you, Teresia. Can you hear me?
Yes, very well.
Yeah, thank you for both presentation. I will come back for next question if there is time, but now I would like to ask Patricia about, she mentioned about heat stress work that has been conducted in the city of Nairobi. And yeah, she also mentioned about, threshold identified with discussion with stakeholders and health practitioners. Yeah, I'm curious to know, yeah, maybe further details what has been done and any data has been analyzed to conduct or identify those thresholds. And what is the status? And we are also at ICPAC. We have a clear project working on heat stress across the region. I think that kind of collaboration also would be valuable. Thank you, Teresia.
Thank you, Titike. Unfortunately, Patricia is no longer on the call because she had to catch a flight. But I told her that I will relay the questions or put you in connection to each other. I especially like the fact that you are already identifying that there could be a point of collaboration. But I don't know if Matt wants to say something here about this, but I will put you in contact with Patricia.
Yeah, thanks, Teresa. So yeah, I think these variables are being identified, and we have in KADI, we have 3 city pilots that are kind of looking at these. So we have these pilot projects going in Nairobi that you've heard about today, but also in Dar es Salaam and in Abidjan as well. And they're utilizing kind of different types of approaches, from low-cost sensors to the Resilience Academy in Dar es Salaam, using or mobilizing students and citizen science to go out and record these variables that you're looking for in terms of temperatures and how that relates to kind of heat stress. And we've also looked at air pollution as well. And then from the Kenyan perspective, I mean, it's much more kind of sensor based. We had the kind of more, I can say, sense of meteorological kind of long-term measurements from these sorts of networks, which is one of our other pilots, kind of lessons learned, looking back in terms of what we've learned in terms of identifying these sorts of variables and thresholds. But yeah, those kind of activities that are going on, different approaches in different locations. But I think those thresholds, should be available. And as Teresa says, we'll put you in touch with Patricia so you can explore that further.
Thank you, Matt. And apologies for putting you on the spot like that.
Always welcome, Teresa.
Are there any more questions? Any questions for Valiet? It looks like there is none, but I will ask one question. I know that the Focus Africa project has ended, but I'm coming from a very general perspective. I think I'm used to that because I'm looking at the projects from a very broad. How have you thought about or ensured that the results of the project remain somehow after or still have impact, even though the project has ended?
Yes, thank you very much, Teresia. This is one thing that we have also been thinking about as we were coming to the termination of the project. And this is where the sustainability aspect of the project had been discussed, and we kind of had an agreement. Although the project has ended, now we're kind of having an agreement between TMA, TANESCO, and the partner WMC, where we're trying to have a memorandum of understanding, where the WMC who is hosting the tool is going to train some of the colleagues from TMA, specifically from the modeling section, who are going to be like handling and maintenance of the tool. And also TMA are going to be the one who are going to provide the products to the TANESCO colleagues. You may ask why TMA colleagues, because the model specifically, obviously, is made for the TANESCO. But while we were having interaction with TANESCO colleagues, it kind of seemed like they don't really have the technicalities in terms of modeling and some sort of things. But TMA has these experts that are good in modeling, and the model itself involves someone needs to know, needs to have the idea of modeling. That's why we decided like TMA could host this model and they could provide these products to the TANESCO colleagues. But also to add, TMA and TANESCO, we have this close interaction. We usually have this stakeholders meeting when we release the seasonal forecast, and we usually come and sit with them and discuss the weather forecast. How is it going to be? So we thought through the existing interaction that we have with TANESCO, it would have been easy. So we're still working on the memorandum of understanding between TMA, TANESCO, and WMC, and hopefully we hope that it will work out just pretty well, and it will maintain the legacy of the project. Thank you.
Okay, thank you very much. We have a couple of minutes, so I will again put Matt on the spot with this question. But now I want to frame it from the point of view of KADI. KADI is a sequel to CICRIFOC. Matt, could you talk a bit about how CICRIFOC led to KADI and how also KADI is preparing for leaving an impact also after the project?
Yeah, I'll try to. So because CICRIFOC was really kind of looking at understanding, kind of where the knowledge gaps were. What did we know? What didn't we know? What data did we have? What data did we need? Where was this data being measured? How was it being measured? It kind of comes from, thinking about, blueprint design for research infrastructures outside of Africa to understand how we answer those key questions. And then, trying to align that with what we needed to do in Africa, because, it's impossible just to kind of pick up this kind of design structure from anywhere else in the globe and kind of just plonk it down and expect that it will work. And so there's lots of work trying to figure out, and that was one of the slides that I showed in the initial presentation today, trying to figure out from a range of perspectives, what did we need to know? Where were the knowledge gaps? How should we measure? Is the way in which we measure in particular places feasible in an African context, to identify this kind of set of variables of what we needed to know. That then also kind of, was in conjunction with other activities that then did some kind of, deep dive statistical work to understand, well, how do we resource this and how do we, kind of implement this? How many observational platforms do we need in particular locations? And then to figure out, where does that kind of, plateau? But that was very specific, and it was really kind of, thinking about this from both the top-down approach, thinking about it in terms of, policy and reporting and kind of IPCC drivers of climate change and what we need to measure in that perspective, versus, starting to think about the kind of the stakeholder perspective from the bottom up and seeing kind of how that met in the middle. Now, KADI has really expanded on that, because that was quite focused, as today's webinar is, on the greenhouse gas piece. But what KADI is doing is then kind of looking much more broadly at cross-domain approaches, the atmospheric science, the terrestrial science, the social sciences, the ocean sciences, lots of different aspects as well. And, thinking about this, as we kind of mentioned in the initial talk, from the bottom up, thinking about the stakeholders in terms of what's the science that people need, and then, what are the kind of the climate services and the ways in which we get the information to derive those climate services. And then that's how kind of KADI has kind of built on the platform of SecraFog to then take this information in terms of what we kind of knew in terms of knowledge gaps, link in with key stakeholders from the ground up to identify what their climate services needs are and how we can potentially address them through a research infrastructure approach. And that research infrastructure, you know, as KADI has evolved, has meant lots of things. It's not just physical infrastructure measuring something in a particular location or a network of sensors. It's about having, I think someone used the term capacity earlier today, but having, you know, capacity on, you know, in terms of the human infrastructure and the resources, in terms of empowered, you know, scientists and these community of practices that we spoke about and stakeholder champions to be able to drive that process in terms of, you know, the climate service, you know, derivation and developing these systems maps to identify what it is we kind of, you know, really need to know for a particular question. Let's take the example of the question that came up, you know, in terms of, you know, predicting, you know, pest outbreaks, you know, in agricultural settings, what that climate service is and what the research infrastructure is to actually provide that climate service in the long term. So that's kind of where KADI starts, you know, thinking about it from the bottom up in terms of the kind of stakeholder needs and how that, you know, kind of builds into climate service requirements through this kind of co-creation process. We've tested that in a number of the kind of the pilot examples, and then we take all that information, and what we're trying to do now, we're at the point of the project where it's really starting to come together in terms of a critical mass of understanding, well, you know, what are the research infrastructure needs across all of these different sectors that address all of these sorts of issues, or can provide information to address these sorts of issues. And can we provide or develop this framework or blueprint? And as I kind of said in my answer to the other question, that allows anybody, any stakeholder anywhere in Africa that's got a key problem or key issue with that needs a key climate service requirement, to be able to take that blueprint and then, you know, kind of, you know, develop a process in which you can think about how to develop the climate service and the data that underpins that. And then, you know, what's the infrastructure requirements in order to support that in the long term. So that's kind of where we're aimed to get to, you know, towards the end of KADI. And then the next phase is as we kind of spoke about in the first presentation, the implementation phase. So that's when, you know, and I may bump this back to Theresia in terms of how we're going about doing this, but then, you know, thinking about how we then explore the wider funding framework to be able to start the implementation piece, but also to be able to provide, you know, long-term support that the, you know, kind of from either a national or a regional or particular geospatial perspective, that organizations within that area can then take ownership and the maintenance of that research infrastructure in the long term to continue, like to provide this continued, I suppose, long-term climate service data and information kind of coming in. Okay.
Yeah. Thanks very much, Matt. I had to maybe put the focus on that because this would be a very good result from this webinar, that we, with our projects, also think about the after, not just when the funding ends. Now we will move to Rebecca Garland, who will be talking about defining climate service needs, especially in relation to air quality in Africa, in South Africa. Rebecca?
Great, thank you. Can you please confirm that you can see my screen okay?
Yes, we can.
Great. Well, thank you very much for giving me a chance to speak today. While I am involved in the KADI project, today I'm actually speaking to something a little bit differently, which is air quality in South Africa, which isn't a specific pilot in the project, though air quality is within KADI. But what I wanted to focus on today is a case study kind of South Africa and the need for the consideration of air quality in the energy transition here, which I think is currently lacking. But it's just a case study. I think there are some aspects that are applicable across many other countries in Africa as well. But first, I wanted to quickly introduce myself and my group. So this is work that's coming from the University of Pretoria in South Africa, the Atmospheric Composition and Air Quality group that I lead, where we focus on developing a stronger evidence base for decision-making, particularly on air quality and atmospheric composition and impacts within Southern Africa. Our region is data scarce, as is most of Africa. And so we work a lot on integrating multiple information and different data, as well as using a diverse range of tools, which the picture is trying to just show some of the different tools and data sources that we use. And then emissions is in gray because to me, it's really where everything starts. It's the basis of a lot of our analysis of air quality and, of course, of climate as well. And we work a lot with data gaps and uncertainty and how that impacts on our results. And we collaborate quite a lot, as well as there are a lot of different skills needed to integrate this information. And I think that's something that goes across a lot of these projects, and we've seen as well, right? We work with a team, as we do have very often smaller groups. So just for context about air quality in South Africa, I would think maybe not everyone knows it in detail. I'll highlight a bit about it. But just to provide some context, we have strong policies for air quality here in South Africa, but our air quality is still quite poor, and it's not improving as quickly as it needs to. We actually need quite a lot of bold action that I'll show later on in order to improve that. And we do have air inequality. We're the most vulnerable. Many places are exposed to the highest levels of pollution. I did just want to highlight as well the areas that I'll talk about today in the short presentation. I talk about some work kind of in Gauteng, which is where I'm sitting, and around this area, but then also in our Highveld, so in this general urban industrial area of South Africa. And maybe in just one picture to convince you, hopefully, that we do have, oops, it changed on my side, but it looks like it's, can you see the red?
Yes, we can see it.
Okay, sorry about that. It's not changing on my slide preview, but I'm glad you can see it. So I just wanted to show one picture to also convince you that we have an air quality problem here in South Africa. These are model output of PM 2.5 on the left-hand side, ozone on the right-hand side. This is an area that includes Johannesburg and a bit south of it. Don't worry about the specifics. The key aspect is that every place in red exceeds our national ambient air quality standard. And so even just seeing that, I mean, ozone, right? That's the one on the right-hand side. We have high levels that exceed our standards of what the ambient air should have. So this is not only this area, many areas see this as well. And currently in South Africa, we have a lot of discussions on the just energy transition. And here, a lot of times when people talk about the just energy transition, if you put it in pictures, it's going from this and our famous Eskom power stations, but also other sources of energy to more renewable. And it's really framed within the work environment, as well as climate change actions and decarbonizing the energy sector. However, air quality is something that's being missed quite often in the discussion here in South Africa. And I've even seen it noted as a hurdle that the management of air quality is putting restrictions on the just energy transition, which is not helpful moving us towards where we have good air quality as well as, clean energy as well. So we know that the transition will take time, and to complete this transition for climate space, moving to net zero carbon emissions, the goals are currently looking at a timescale of up to 2050. But currently we have poor air quality, and there are aspects that we can do now that during this transition that can really help to improve our air quality. And this is just, I wanted to highlight this as well here a bit, because it's not really being a focus of the just energy transition. So one example to motivate this is a study that my group did looking at the impact of Eskom emissions. So Eskom emissions are mostly, when I showed the map, are in the industrial Highveld. So this is an area, if you look at the map, we have the cities of Johannesburg, Tshwane here, and we move over to where a lot of our stations are. There's a lot on this map, but the key one is sitting here at the bottom, which is showing the difference between a model run where we had our Eskom power stations on and we turned our Eskom power stations off. And we looked at the impact of PM 2.5, which in one of that first graphs showed about half of the area in red of that particular domain that it was out of exceedance with standards. And this whole area also is out of exceedance with standards for PM 2.5. So if we shut off Eskom completely, we see in these large areas, the largest decreases, which are these blue areas, would be about 3 micrograms per meter cubed for the annual average, which is an improvement, but it's really not enough to solve the poor air quality. But as I mentioned on the last slide, a lot of the just energy transition is focusing mostly, let's say, on electricity and not looking, I think, as holistically across other measures that can also be reintroduced to move away from fossil fuels, decarbonize, but also have immediate air quality positive impacts. And if we look at our sources, this makes sense that it would be a very small decrease from just ESCOM alone. This is now an emission space, not an ambient space. And this is an emissions inventory for Gauteng. The key thing is if we look at pollutants, right, we see a whole bunch of different colors, which are all of the different sources, as we would expect. And as we know, we have many different sources that contribute to pollution. And if we look at the ones, the airport, home, industrial, and road, these colors I've highlighted, these are our contributions from fossil fuel, and we see them come up in a lot of our pollutants. So if we look broadly across fossil fuels, we would be able to have, if we decrease those emissions, we would have decreases in emissions. Industry is not the only sector, and industry doesn't highlight here as heavily, mostly because the power stations aren't in Gauteng, but also, in emission space, our industries and our power stations do dominate. But as I showed on the last slide, they don't always dominate our ambient. And this is particularly true in our poorer areas in the low-income settlements where they use domestic fuels for heating and cooking. Our levels of PM there are the highest usually. And so this is still fossil fuels, but it's not just the electricity generation sector. And just, I know I have just a couple minutes, so just to finish up, 2 more slides on another analysis we did, again, looking at Gauteng province, where this is showing in emission space how we would get to meet our standards. So again, that very first slide with the red that I showed, we highlighted for PM 2.5, we didn't meet our ambient standards across a large area of our domain. And so if we look at our emissions currently, this was 2020, but a non-COVID 2020, we then modeled what would we need to get to 20 micrograms per meter cubed, which is our annual ambient standard right now. And if we look in 2030, from the baseline, if we just continue where we are, down to get to 20 micrograms per meter cubed, the key thing here I just want to highlight is this large decrease. And this bold action, this large decrease is much larger than is currently within a lot of the policies in South Africa. And so bold action is really needed. And if it can be reflected in climate mitigation as well, then that could also help to improve air quality. And then just to highlight here, this is the same study, an analysis, again, highlighting the diversity of sources. If we look at the sources across Gauteng province, we see about 5 micrograms per meter cubed on average come from natural sources. Another 5 or so come from outside Gauteng. And then within Gauteng is where the rest of the pollution comes from, with all different sources contributing to it. All of these have really high uncertainties. And one of the things that can help with this uncertainties is more detailed measurements, such as those that could be in a research infrastructure. So just to conclude some final thoughts. So in the just energy transition, as I'm seeing it currently in South Africa, the energy, climate, health, air quality nexus should be considered, but it's not yet. We do have a great potential to improve the air quality in this transition, but the nexus really is being overlooked. And there can be negative, even unintended consequences to air quality and health if it's ignored or not prioritized, which is shown, at least in air quality circles, we see this graph often where different types of interventions can be good for the climate and good for air quality, but also other ones can be good for air quality and bad for the climate and continuing on. So good for climate and bad for air quality, as we all saw with diesel vehicles, for example. So it's really critical to, assess what climate services are needed in this transition, also with air quality in mind. Our research is trying to support what pathway through this transition could we do to continuously improve air quality, but there is a lag in assessing climate futures holistically. And integrated research and climate services are needed across this nexus. And so there is a role, as we can see for KADI, and we know this already, in developing an impactful research infrastructure that does look at this holistically. And with that, I'd just like to say thank you very much for the time to talk about this.
Thank you very much, Rebecca. That was a lot of good information in such a short time. Does anyone have questions for Rebecca, especially because she is in between two meetings? Any thoughts on the presentation? Any questions? Any comments? While you are thinking about your questions, okay, Valiet is here to speak. Yes, Valiet.
Yes, thank you very much, Cersei, and thank you very much, Rebecca, for the detailed presentation. I was wondering if you could tell us the source of the air quality data, and if by any chance you have done some sort of verification to maybe check on the quality of the data that you have just used. Thank you.
Yeah, so actually a lot of what I showed were more model results, but of course we compare it to observations. And so in South Africa, we do have a network of regulatory stations, and I can put the link in the chat as well when I'm done. And so we have more than 130 of these regulatory stations across the country, which use the reference methods to measure the air pollution. We also had a couple source apportionment studies that we used to validate the model to see if the composition that we're simulating is similar to the compositions that were measured. While we do have this regulatory data of air quality, the data capture and data quality and when the instruments are running is a little more variable than I'd like. So we do quality control of the data, but because it is it's supposed to follow, and it does follow standard methods, we don't go more above the normal data quality analysis of the data itself, looking for negative values, looking for drift, things like that.
Thank you very much. In addition to that, you mentioned there are some sort of sensors, 130 something. Specifically, where they installed or deployed? I'm asking this because we're also, I think last week or last 2 weeks, we have had an engagement with this company named Say from Stockholm. And we have been having sort of a conflict of interest. We were not really sure if they should engage us or the Ministry of Environment, because their main aim is trying to deploy these air quality sensors. And we were kind of we were not really sure if we should take the mandate in installing these sensors in along with the weather instrument, or maybe whether the Ministry of Environment should take that mandate or something. So I'm just gonna try to see the relevance of something.
Sure. Yeah, and I'm happy to talk more after as well. I can put my email in the chat. So the data that I'm talking about, these are regulatory sensors that are mostly in urban areas and industrial areas. So we do miss the rural areas that have maybe high pollution or outflow. They are, because they're regulatory, they sit within our Department of Environment's Forestry, Fishery, and the Environment, but they are, the database is operated through the South African Weather Service. And these aren't sensors, these are reference monitors. We do also in South Africa are increasing our use of these lower cost sensors, some of which the Weather Service is starting to bring into the online platform to look at the data. But it is a discussion because the 130 or so, those are reference grade, those are for long-term measurements, so on and so forth. And the lower cost sensors need to be corrected, are for shorter term. There's a lot more questions on those. So this is also a discussion, not necessarily as much on the who's, we have already, the department and the Weather Service have already sorted out who's doing what, but how to use this information is very much still discussion. So I'll put some information in the chat, and please, it would be great to speak more as well.
Thank you both. Thank you both. I think this is a good discussion which can be continued also out of here. That's one of the objectives. There's one more question for you, Rebecca, before we go to the next speaker. It's in the chat. Are you thinking of a follow-up project? In other words, what will you need more long-term?
Yeah, so we are continuing. This is the research, one of the research areas that my group does. And so we will continue to work in this space. Some of the aspects that we need more of, first off, are the data scarcity. And this is more than just air quality data. This is health data. This is aspects on, for example, if we want to analyze different scenarios, many industries won't share with us what their emissions and what management measures they're already doing. So we don't always know if what we simulate, the scenario is correct. Maybe they've already done that, but they won't tell us, and so it's difficult to know. And also another aspect that is really scarce in South Africa, and I would imagine, talking with other collaborators, it's very similar in other regions, is the ability to do such detailed atmospheric modeling. I know there's many modelers on this call right now. I would assume they have the same challenges I do in getting, PhD students really with the abilities to work with these large data and to run these complex models. And it would be great from a long-term perspective to continue. I know small projects bring people who do that together, but really to continue, I think, with that developing networks and linkages between that type of really technical skills and people who have it and use it, to make certain that it grows in many places. Just a few things off the top of my head.
Okay. Ellie was the one who asked the question. She says, thank you. So now we can go to the next speaker, who is Nebiyu Girgibo. And he will speak about climate services in Libreville with a project example. Maybe you have the floor.
Okay, thank you. Can you see my slides? Not really. Do you see my slides?
No, we see the participant screen now.
What about now?
Now, yes, but not yet in presentation mode.
Is it or no?
No.
Okay. I will start again.
While you're figuring that out, Rebecca, if you're still here, you said that the air quality policy in South Africa is strong, but there is no bold action. What do you think could be the solution to that?
So I think one of the challenges, and this was, so a couple years ago, we had a constitutional court case which reaffirmed the constitutional right for every citizen to a clean environment and good air quality, because in the Highveld region of South Africa, this was our constitutional rights were not being upheld, and one of the parts that the judge noted was the lack of intersectoral discussion. And I think that is it's very common, right? In a lot of these environmental issues, the environmental department is supposed to improve air quality, but mining actually has to do something about it. Transport actually has to do something about it. And here climate gets a lot more attention than air quality. Sometimes they sit in the same area, sometimes they don't. And so those types of linkages, and really, I think, while departments may be seeing climate as something they need to be considering, they don't always see air quality. So I think that's one one, the intersectoral collaboration that's always an issue with environmental issues is one part of it.
Can you show? Okay.
Yes,
Hello.
now we see the presenter screen.
In
I think it's
presentation more?
yes. I
Okay.
think you should go on. We
Okay.
can do with this.
Uh,
Thanks, Rebecca.
okay. Can you see it in presentation mode? Because
It is, even though it's the presenter screen, but I think it's fine. We can go with that.
the presenter screen, okay. What about this one? Now?
Yes,
Better?
now it's good. Yeah.
Okay.
Yeah.
Thank you. My name is Nabi Yurgibo. I work in University of Basa, and this is a LIPRI project. We are work package 40. It is called Energy Village Concept in Africa. The title of the project. So thank you for inviting us to present here. Energy Village concept has been started here in University of Basa about 20 years ago, and it has several. It is like a research concept that identifying renewable energy resources so they can replace fossil fuels. Here today, our project has started June 2021, and it will end May 2025 in paper. Actually, it will end next month according to our finance. There are 4 countries: Finland, Ethiopia, Botswana, Uganda, and Kenya, all represented by their universities. And the main objective is the goal of the project is to develop and promote sustainable energy use in village. So we are aiming to replace fossil fuels in rural areas. Basically, so we aim to create energy self-sufficient village, and also make the concept known, as well as African-wide network can really has been planning, and that's the roadmap is more mapping joint research as well as smart and knowledge systems would be the next steps after this research. So we have identified 60 different energy villages in Ethiopia, Kenya, Uganda, and Botswana, both on grid and off grid. And we have gathered data, also analysis more or less has been done. Even we have managed to make some article which has been submitted to Renewable Energy Journal, and last deliverable is only missing because there is only, and the final reporting remains. But this whole concept of energy village is that helping rural areas by finding their potential in renewable energy resources. I am presenting today 2 small cases as example how they can differ one to another. Our case villages are in Kenya. These are 5 of them. In Uganda, there are 5. In Botswana and in Ethiopia. Now I will go through the 2 cases which are BDBD refugee settlement and ACTU campus. So I am trying to show how much climate change can be helped by replacing their use of greenhouse gas emitting fossil fuels with renewable energy resources. So one of inspiring cases is Ethiopia, AICT campus, which is Addis Ababa Science Technology University campus. So they have we with our partner from that university has analyzed and found out that their consumption and their potential. The potential has been renewable energy resources from biomass, food waste, fuel waste, human waste, solar and wind, and they have estimated, and you can see that how much the amount of potential kilowatt per hour per day is much higher than the consumption currently. Currently they are using firewood, which can emit some kind of some smokes that that also shows Rebecca's presentation. Air quality has been affecting locals while they cook at least, and it will also contribute to climate change effects. And the other one is charcoal they use, as well as fuels. And well, electricity in Ethiopia has been more or less from hydropower, but fuel has been also influenced. So this case shows that how much one easily can identify and show locals how to use it. This is just, we just have a research project, so we have identified our next step is to implement such projects, such physical means to overcome the problems. The second one is Uganda BDBD Refugee Settlement Center, where they have a potential of harnessing in renewable energy resources, about 50%. There are 100,000 refugees there, and the biogas can replace about 40% of the energy demand. Additional needs can replace by solar and wind. More development acted as a guide in energy supply strategy. This also highlighted some of the challenges, policies and the regulations are challenges in Africa project implementation. In our current deliverable, we have noticed, or not in our paper, how we have noticed several challenges like authority challenge in some countries, security issues has been a problem, and not providing data. I am a bit away from the case, but those challenges has really highlighted us, like open our eyes. There are already expectations while we are going from Europe or from Finland to Africa, so that even shown me my original country, which is Ethiopia. There are really cases we locals only know to identify. So going back to the case, Uganda case, we have Uganda case has been the opposite. That means the potential has been lower than the consumption, but the other option is that to have a bigger biogas plant, let's say, or like double or double, maybe even triple level of biogas. Large biogas plants can really help the refugee settlement if there is really enough waste for the biogas. That's correct. And this shows that different cases or different villages can really have different issues. As a climate change service, I mean, as a service, it means this is one way of showing or teaching locals, engaging locals really to overcome or no, they cannot overcome climate change, but they can contribute in mitigating and as well as also combating climate change by using local renewable energy resources. They can really show their commitment and their capability in helping the world's challenge, which is climate change. As a conclusion, all in all, these two inspiring cases represent how different situations can be in village, and not all of them can act as the same energy village. It means case by case climate change issues or services, if we not going to the service side, but issues of climate change can really differ from local to locals. One area they might prefer to use fossil fuels, the other area might have, let's say, some emissions due to factories or some kind of issues. So such cases can really affect. The projects can help us to learn much about how to apply, what to expect by implementing energy village concept in Africa. In our last deliverable, we have identified a roadmaps, which is just delivered yesterday, I guess. So those roadmaps can really lead to the next stage of implementing new technologies to help locals. There is a promising league energy village, can be self-energy, self-sufficient in the replica for others. These inspiring cases of or most of these energy villages we have identified, analyzed, and showed that can really help locals as well as are ready to implement new renewable energy solutions. Those are really locally available. It is the case introduced in here as very unique, and they are different to each other. Almost 60 of them are almost different. I mean, almost there are similarity to some level, but even in one country, 4 cases can be quite different, even the locals condition. And this shows us in Africa there are really thousands of such cases that can be really useful for energy consumption or to help locals. The energy village concept and the proper solution can be customized to fit the energy demand of a given village. So each given village has really its own potential and its own drawbacks and challenges. So to you or to you partners or to you people when going to Africa, you should really study case by case. Otherwise, the project might have challenges. If there is no difficulty, there might be some challenges. Thank you so much.
Thank you, Nebiu, for that presentation. I really liked the fact that the project thinks about replication, about self-sufficiency, and also the possibility to customize according to the particular context. So now we would give 5 minutes for questions directly to Nebiu before we go to the next presentation. Any questions from the audience to Nebiu? Yes, Leona?
Yes, thank you very much, Nibiu, for the presentation of Energy Village concept. I think it's one of the most relevant projects when it comes to both embracing climate and energy within the LIPRI portfolio. So I was wondering whether you intend to apply for a follow-up project as a continuation of the Energy Village concept.
We were planning, but I have noticed from LIPRI sustainability country list, Finland is not really listed. Why is that, Leonard?
No, indeed, Finland is not acting as a funding agency, but I was thinking potentially to other funding opportunities in addition to LEAP Energy ecosystem, let's say.
Okay, so we can really apply as a partner for. Did I understand correctly, Leonard?
Well, as Finland is not actively committed as a funder into the call, it means that no, your organization would not be funded within LEAP SECO fund mechanism, but you could apply with your own resources at the University of Vaasa. But I guess this is not a strategic decision to make. But I was thinking about potentially another Horizon Europe call or something related to capitalizing on the excellent project that you have been delivering.
Well, there has been several projects already. As far as I know, before our project, there has been about 4 or 5 energy village related projects in University of Vaasa. Now, currently, if I am correct, there are 3 or 2 projects which are going on in Finland as well as in EU level, which has been delivering these concepts, but not in Africa. That's the drawback, because the only project I was or our group has been able to get it is through LIPRI, and now LIPRI Sustainability has not able to provide us funding or to allow us to apply for University of Vasa. So Africa continuation might be difficult. It's not possible for University of Vasa because I am University of Vasa member, but our partners from ACTU, Mo University, Botswana International University, as well as Makerere University, they have, I would say, more or less the concept idea and the whole resources, so they can apply to continue with it. But it was my dream to continue to help Africa, but unfortunately not with LIPRI currently. I hope maybe in future.
Thank you, Obi.
Okay.
Thank you. Titike.
Yes,
Titike, you have the
thank
floor.
you. Yeah, can you hear me, Teresa?
Yes.
Yes, yes.
Hello?
Yes, we hear you very
Okay.
well.
Yeah, so thank you. Yeah, thank you, Nebi. I just want to kind of explain further. So Leonard was suggesting you, are you willing to join another consortium if you are invited? That's a kind of a blunt question. Probably there are some expected calls to sustain what you have started. That was the question. I hope we'll communicate further.
Yeah, we would love to if we are allowed to. Yes, of course.
Okay. Yeah. So my question is, yeah. So do you have in Hawassa University? Do you have like a climate group, or the people who are kind of working or doing research in the climate? And do you have some sort of partnership already established with your group? And that will help you, for example, besides energy village, you can map energy potential, solar energy potential, wind energy potential in a certain area based on the climate information. Do you have any such partnership?
Not really. Actually, our group has been dividing because it was a large group, only renewable energy resource group, still the same name, but now they are focusing it more or less to like engine technologies, and we are 4 or 5 people who are now working here in this department, in energy technology department. But we have other platforms like VEBIC, Vasa Energy Business and Technology unit. They have several projects. As climate change expert, I am probably the only one who has been currently actively working in our department.
Yeah, thank you, Navi.
Okay, thank you.
Okay, thank you. That's also another discussion that can be continued out of the call. We will move to Suzanne Onyango's presentation, another example of climate services in LIPRI. Suzanne? Suzanne, we can see your presentation. It's not on the first slide though.
Yes, we can still see the presentation. I think if you click the first slide and then you just the full slideshow.
Do you hear me?
Yes, we do. Very well.
Okay, so thank you very much, and good afternoon to everyone. My name is Susan Onyango. Part of the LIPRI project involved in actually 2 projects, the Geothermal Village and the Geothermal Atlas for Africa. So in these 2 projects, I am affiliated to an organization called Geo2D. So I'll present on behalf of the LIPRI, these 2 LIPRI projects, as well as Geo2D. I've titled my presentation Data-Driven Geothermal Development for Climate Change Mitigation. So those are the 2 projects that I've talked about, the Geothermal Atlas for Africa, which is Work Package 9, and the Geothermal Village 1, which is Work Package 11. Just to very quickly give a quick overview of the Work Package 9, the Geothermal Atlas for Africa. It's a project that was aimed at mapping relevant information of geothermal resources. This was in terms of geoscientific data, technological data, and socioeconomic data. And the aim was to get this data in a form that would make it easy for people to make decisions around electricity production and a range of other direct uses in Africa, but using geothermal resource. This Geothermal Atlas for Africa was targeting quite a number of countries in Africa. But if I speak more of the socioeconomic part of it, it was focused in 8 African countries: Ethiopia, Kenya, Djibouti, Rwanda, Mozambique, Algeria, Egypt, and Tanzania. The project activities was in such a way that it was to identify, organize, assess, classify, and interpret given sets of information to define the origin and location of low to high enthalpy geothermal resources. And what this means is basically that if I start from the point that there are parts of Africa that are well endowed with a geothermal resource, and these resources have until now not been used very well. In the context of climate change and climate change effects, geothermal is actually one of the renewable energy resources that can respond very well to some of the challenges faced with climate change effects. And the second project activity was linked to the making this information, the geothermal atlas, accessible to various audiences, particularly researchers, people involved in project development, targeting geothermal resource, investors, policy formulators, and decision makers of different types. So in fact, that information is already available. There's already a geothermal atlas for Africa that's online, and one can consult it based on the different information that one may be looking for. In terms of climate change aspects and mitigation issues related to the Geothermal Atlas for Africa, we see that out of the countries that I've talked about, basically Africa is one of the least emitters of CO2, but most affected by climate change effects. Some of these countries have fragile ecosystems, which are very vulnerable to drought and floods. So of course, this already brings in a very strong aspect of climate change effects. And the fact, it also, this whole aspect of drought and floods brings in the aspect of water and energy provision. Again, something that is very strongly linked to climate change effects. But also water and energy is relevant here because geothermal resources can be used to provide water and energy. We see that, for example, in some of these countries, energy provision is in the form of wood. Fuel provision is in terms of wood, whereby women will usually have to walk long distances in search of firewood, for cooking and for other energy provision uses. So climate change related, well, one other point that brings in the link of the Geothermal Atlas for Africa project to climate change effects and mitigation issues is the fact that the climate change related project developers, investors, policies, and decision makers are a target audience of the final product of the project. That is the map that is now available online. If I go to the second project, which is the Geothermal Village, we called it Geothermal Village 1 because this was the first phase of doing a research with the objective of coming up with data that would enable us to be in a position to put in a strong proposal that now comes up with a proposal for a demo on site, a real project now on site. And the aim of the Geothermal Village 1 project was to introduce geothermal-based standalone electric and thermal energy systems to off-grid African communities. The aspect of off-grid African communities already brings in an aspect of climate change effects because of some of the issues that I've already mentioned, that these will be communities which have no access to electricity and therefore, and also no access to any other form of energy. Their main source of energy is usually firewood, which it ends up being a vicious cycle because this firewood means that they have to at times cut down trees, which again bring in deforestation, and the vicious cycle of climate change effects then just kind of goes on and on. The geothermal village focused on 4 countries, Eastern African countries, Ethiopia, Kenya, Djibouti, and Rwanda. In terms of our project activities, the objective was to produce data that could lead to electricity production, and also data that could lead to information related to thermal energy for direct use. And this is where the aspect of using geothermal for agriculture, drying, manufacture, greenhousing, and other things like tourism comes in. If I go on to the climate change aspects and mitigation issues related to the Geothermal Village 1 project, very similar to the ones of Geothermal Atlas, only that this particular project, the next phase aspires to have a demo project on site. But really same issues, more or less to do with that the four local communities that we worked with in the Geothermal Village 1 project are some of communities that are some of the least emitters of CO2, but most affected by climate change effects. Still, the issue of fragile ecosystems comes in, whereby we are talking of populations that are very, very vulnerable to drought and floods. And the aspect of water and energy provision, again, is a climate change issue. And the fact that water and energy geothermal can be used to provide water and energy, and these communities, because of climate change effects, are facing issues of deficit in terms of water and energy. And when I talk about water and energy here, I'm, for example, looking at the fact that then they end up having crop failure. They end up with situations whereby their livestock will die because of water shortage, because of drought, because of lack of pasture. The men have to walk longer distances searching for water and pasture for their livestock. So again, the same issue of climate change effects. And the reason why some of the activities of the project, again, that I've talked about earlier on, that are related to direct use of
Susan, we are about at the end of your time.
Okay.
Yes.
The reason why some of the issues I've talked about, like agriculture, drying manufacture, and greenhousing comes in, because if I talk of livestock production, livestock keeping, for example, growing of pasture would even also be one of the things that the geothermal village project could be used for. And I'm done, I guess.
Thank you, Susan.
Okay.
Now we can have time for a brief discussion. Does anyone have questions in relation to Susan's presentation? Valiet?
Yes, thank you very much, and thank you very much to Suzanne for a nice presentation. I had a question. I am sure Suzanne would know of the saying, probably it's a research, that geothermal energy is one of the most expensive energy to harvest, at least in Africa. Now, I was just wondering how is it going to be sustained when you're going to try and provide geothermal electricity to some of these off-grid communities?
Okay, I think one of the things to bring out is that you are probably talking of the classical approach to geothermal development. And of course, I didn't have time to get into details, but the kind of geothermal development that we are talking about is community-based geothermal development, which approaches geothermal from the point of view of shallow drilling. The classical approach has been more focused on deep drilling to provide, to use geothermal for serving the national electric grid. We are approaching geothermal development from the point of view of small community-based projects that serve socioeconomic needs of the local community. So the drilling is not deep, it's shallow drilling. We are talking of plants that are not the big plants that we've been used to seeing in classical geothermal development. We are looking at plants which, for example, would fit in the back of a pickup, for example. So then the costs are not as high. And then geothermal is a 24/7, what do I say? How do I put it? It's available 24/7. So again, there's a lot of positive things that come with it. It's not weather reliant. For example, it's 24/7 basically throughout the year, 12 months of the year. So there's a lot of cost effectiveness that comes in with that, even if we look at it from the point of view that there may be the capital at the beginning may be slightly higher, but yeah, there's all those advantages that I didn't talk about.
Yeah, thank you very much, Suzanne, for the awareness. Thank you.
Oh, okay, you're welcome.
Okay, thank you. But I don't know if anyone else has a quick question. We are exactly 2 hours here now, but I crave your indulgence because of the short breaks with technology that we had in between, that we take this to the end. I will skip the agenda item joint discussion and go to the future collaboration perspective from Leona. This joint discussion question can still be touched on, maybe on the Libri app. I will put that there under this event and you can join the discussion. But I think that we should go to the wrap up, Leona, if you are ready.
Yes, thank you very much, Teresia. So I'm very happy that we had this opportunity to address both climate and energy topics within LIPRI and KADI project implementation. I think it was part of the European Commission expectation. As you know, they drive the climate change and sustainable energy working group. So I guess there are some very important inputs that should be shared with them regarding this potential alignment between climate and energy topics. I see plenty of very exciting and efficient projects addressing both energy and climate, but I see also plenty of opportunities to advocate for further fundings and continuation of efforts, precisely in the field of financing, scalability, also local capacity, because I think we are here addressing the most vulnerable communities when it comes to energy village, when it comes to the fight against air pollution, and so on. So I think it's very important to coordinate our efforts to address these challenges. And happy to schedule a follow-up webinar, if it makes sense, with you all and potentially additional contributors. And I would like also to raise the opportunity that is still open related to the LEAP Sustainable Energy Co-Fund mechanism that is open until the end of March. So everything is available on LIPRI website, the detail of the call for project, the eligible countries and entities, and there is a generic email address whether you will have any question to ask in the view of potentially applying to this call. So thank you very much for the good organization, for the participation. I think this webinar has been recorded and will be available directly on LIPRI platform. So yeah, I think we can stay in touch and schedule something else if relevant. Then thank you, Teresia, for the good moderation.
Thank you very much, Leona. Before we end, I have a quick question for you. Can we hear a bit more about the matchmaking tool?
Well, this is a feature that has been developed very recently on the LIPRI platform. So once the meeting is over, you can click on the right corner of the main menu to check the matchmaking tool. Basically, this is a space where you can list if you have a project ID in order to look for potentially additional partners. And reciprocally, you can also publish a project ID in order to look for an expert or someone that can contribute to improve your consortium. So this is brand new. This has been launched actually a few days ago. So I hope it would be useful in the view of preparing potential submission in the view of this call. But we are also very open to receiving your feedback on the way you use the tool, your user experience, because this can be easily adapted. You know, the whole LIPRI platform is managed by my company, LGI, so it's very easy to improve, to adapt. But the main element is that we need to receive feedback. I would like also to stress the fact that we created a specific Q&A session that is dedicated to LEAP SE Coffin call. So there is a help center in the main menu. So I think so far the content is not ready, but ANR coordinating the LEAP SE Coffin mechanism will soon detail and bring some elements of answers to have directly on the platform a center of resources for any project leader that would like to apply and has questions towards the call.
Thank you very much, Leona. And it was just added in the chat that you need to be registered to the Libre app to access these possibilities. Thanks everyone for today. I think this was a good interaction, and I see a lot of possibilities for collaboration. Thanks, Leona, also for mentioning the fact that we could have a follow-up discussion. We will think about that, and also some form of communication to the European Commission about this, so that they know that this is a developing cluster and we need, as always, funding to continue the good work that we are doing. Thanks to the participants and the speakers and everyone else. Have a nice day.
Bye-bye.
Bye, everyone.
Bye, everyone. Thank you.
Okay.
Bye.
Thank you. Bye.